Leucine is one of the 20 amino acids that's used to make proteins within the human body. Just like every other amino acid, leucine has a central carbon to which there's 4 different attachments, which makes it a chiral carbon or the alpha carbon. One of those attachments being a carboxylic acid or a carbon with 2 oxygens and a hydrogen. An amino group where you have a nitrogen attached to 3 hydrogens attached to the central carbon. This nitrogen should only have 3 total attachments, so the fact that it has an extra hydrogen attached, it's going to carry a +1 charge. Then it's going to have just a hydrogen attached to that chiral carbon. And then the way that each amino acid is different is the R group, or the final thing that's attached. And in the case of leucine, this R group is going to be straight up carbons and hydrogens. So at the lowest pH, all of the hydrogens that can possibly be on this molecule are going to be on this molecule. The environment has extra hydrogens that it's able to give up, so every part of this molecule is going to have a hydrogen where it could have a hydrogen. As you start increasing the pH or losing hydrogens in the environment, this molecule is going to have to give up some of its hydrogens to the environment to help balance things out. The first hydrogen that's lost from this molecule is going to come from this carboxylic acid, and that's going to happen at a pH of about 2.3. At this point, this oxygen is going to have an extra pair of electrons. And so because of that, it's going to carry a -1 charge. This nitrogen still is going to carry this +1 charge. And this has no charge, it's just carbons and hydrogens. So because of that, -1 here and +1 here, this is going to overall balance out to 0. But it's going to be known as a zwitterion because there is actual places on this molecule where there are formal charges of -1 and +1. So now if you keep going up, or losing hydrogen from this system, the next place that's going to be lost, this hydrogen is going to be lost from this nitrogen, and that nitrogen is going to gain its lone pair back, and now this nitrogen is going to be back to neutral. This happens at a pH of about 9.7. And so at this point, we've got a -1 here, and we've got a 0 charge here. This still is 0 charge. So -1 and 0 equals -1. So here, this molecule is going to have a charge of -1 above a pH of 9.7. At physiologic pH, which is about 7.4 and is the pH your body is normally at when it's healthy, this is what the molecule is going to look like, where this nitrogen does have extra hydrogen attached, and this oxygen has lost its extra hydrogen attachment, and it's going to carry a -1. So the zwitterionic form is the form that predominates in the human body. Now let's talk about the R group. The R group of any amino acid is what makes it special. And in this case, it's just carbons and hydrogens. Carbon and hydrogen have a similar electronegativity. So all of these bonds are going to be completely nonpolar. Because they're all nonpolar, there's not going to be any moments where it's going to have more sharing of electron in one element than another. And so there's no ability for this to do hydrogen bonding. So leucine is considered a hydrophobic and nonpolar amino acid. If you look at this R group, you'll see that this carbon has 3 different branches of other carbons. It's not just all in one chain. You can go this way and then there's still an attachment, or you can go this way and there's still an attachment. So because this is a branched chain, this overall amino acid is considered a branched chain amino acid. All of your branched chain amino acids, this is too bulky of something for you to be able to make within your human body, so you have to eat it. So leucine is an essential amino acid. You have to eat it in your diet in order for it to show up in your body. This amino acid can be converted into other things within the human body, one thing being acetyl-CoA, which can go on to make fatty acids. And fatty acids start as ketone bodies. So because this can be made into acetyl-CoA that can eventually make a fatty acid, this is considered a ketogenic amino acid. Leucine is a ketogenic amino acid.